We experience time as a relentless, universal metronome, a ticking clock in the background of the universe that moves forward at the exact same rate for everyone, everywhere. Under this assumption, the order of events is indisputable. Action leads to consequence. The glass always drops before it hits the floor. In 1905, Albert Einstein proved that this universal clock does not exist. He showed that time is flexible. It bends, stretches, and flows at different rates, depending on how fast an observer is moving or how close they are to a massive gravitational field. Two people in different parts of the universe literally experience the passage of time differently. This creates an immediate paradox. If time is a wobbly, subjective mess, why does reality hold together? If my clock is ticking slower than yours, why do neither of us ever see a glass shatter on the ground before someone drops it? A hidden, rigid architecture underneath reality must strictly enforce the order of cause and effect, holding the universe together even when time itself is subjective. This animation shows a 3D wireframe of a room collapsing down into a flat, two-dimensional grid representing space. This is the first step in building a Minkowski space-time diagram, a mathematical map used to translate our chaotic reality into clean geometry. To map reality, we add time as its own physical direction, rising straight up from the center of the grid. Moving outward on the flat plane means traveling across space, while moving upward means moving forward into the future. We can plot a single instantaneous event, like snapping your fingers, by marking that exact physical location and exact moment with a point at the origin. We'll call this event A. If someone across the room hears that snap a fraction of a second later, we plot that as event B. It happens further out in space and slightly higher up on the time axis. To show that the snap caused the person to hear it, we draw a line connecting the 2 points. This ascending line represents the fundamental geometry of cause and effect. It shows that for an action to create a consequence, it must travel through both space and time to reach its destination. This brings us to a hard physical limit. What is the absolute fastest that event A could possibly influence event B? If we replace the finger snap with a flash of light, that light radiates outward in all directions. On our map, it forms an expanding circle across the flat space grid, while steadily climbing up the time axis. The three-dimensional shape left behind by this sweeping motion is the light cone. Everything you can ever interact with, influence, or see in your future must exist inside these walls. The dark space outside the cone, labeled elsewhere, is structurally disconnected from your present. No signal can reach it. No action can affect it. This boundary is absolute. The outer edge expands at exactly 299,792,458 meters per second. The speed of light represents the physical, geometric outer edge of the light cone itself. This perspective reveals the cosmos as an infinite tapestry of overlapping, intersecting personal light cones, each defining the strict boundaries of what can affect what. While light travels at this maximum limit, the number actually represents the speed of causality, the expansion rate of reality itself. Faster than light travel would require moving horizontally across our diagram, stepping completely outside the boundaries of your light cone. Similarly, backwards time travel requires a trajectory that pierces the wall of the cone to loop backward and outside the base of your current reality. Stepping outside the cone means outrunning causality, allowing an observer to see an effect happen before its cause. A shattered glass would suddenly leap upward from the floor and perfectly assemble in midair before it was ever dropped. Faster than light and backwards time travel are geometric impossibilities that would unravel the logic of the universe. Despite the relative nature of time, the rigid, invisible architecture of the light cone protects reality. It guarantees that no matter where you are in the cosmos, the glass will always drop before it shatters.